Today we're gonna be working on Leetcode question number 260, single number part 3. So we have been given integer array nums in which exactly 2 elements appear only once, and all the other elements appear exactly twice. So let's get to this example, and we have to do it in the linear algorithm, like the time complexity should be linear and we shouldn't be using any extra space. So in this example we have 1 which is used twice, 2 which also came like 2 times in the nums, and we have 3 and 5, only 2 elements which occurred in this nums only 1 time. The algorithm which we're going to be using is very similar to the one in which we were looking for a single number and we just XOR'd all the elements and we ended up with that unique element, right? In this case, we're gonna do that first, and we're gonna come up with this XOR like result of all the elements so that we can have a unique number, right? But that would be kind of product of two things, right? It will be basically the XOR of two elements, right? So what we're gonna be doing is like we're gonna be looking for the we're gonna be looking for the uh, we're gonna be looking for the last set bit, right? We're gonna get it last set bit, and then we're gonna once more we're gonna XOR all the elements, all the elements or all the integers in that num with that like we're gonna check that uh, we're gonna check if we once we have that last set bit, we're gonna check if we end the number and that last set bit, if it becomes equal to 0, that's gonna be 1. Like we're gonna keep XORing that. So that's gonna we're gonna once we iterate all of it, we're gonna get the first element, and if it is not equal to 0, uh, when we actually do the bitwise AND of that last set bit with all the numbers with the number, we're gonna keep XORing that in order to get the second result. It's gonna become much clearer when we write the code. So in the first iteration, we're trying to get the XOR of those two unique values. So we're gonna call it, let's just initialize the difference equal to 0, and then the difference is gonna be good. Okay, once we have that XOR, we're gonna try to get the last set bit. We can do that by actually taking the negative diff and then ending like bitwise AND with itself. That will give us the last set bit. As an example, you can see that if we have 4, right, which is gonna be equal to 100. So what I'm trying to do is like negative of 4, which I have to do a 2's complement here. That will give me -4. That will be just 1's complement is gonna be 100111011, and then adding 1 to it is gonna make it this, right? So if I AND that thing, so the last set bit would be this one. So if I do 4 and -4, it's gonna give me 0100, which again itself is 4, but that is the last set bit. So once we have that, I'm gonna initialize my result with both of them being zeros, and then one more time we're gonna iterate through all the the num inside the nums. Right. Now we're gonna do two things. One, if we add the number diff with the diff and it becomes equal to 0, if that is the case, we're gonna say that the result of that 0 XOR equal to the num. Otherwise, we're gonna assume that this should be XORed with the second element. And once we are out of that, we can just return the result. Did not like that. And it works.